everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class, that is been the computer based numerical and statistical technique, which has been the classes 31th class. We had done your 30th classes in the last session, where in that we had done your unit 1, which has been the computer arithmetic and numerical and statistical technique, which is we had done here. And now we had started with unit 2, which has been the interpolations and your curve fitting, that has been the unit 2. And now we go ahead for continuing these what we had done in the last classes. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So first of all, we'll start with the question here. The question is, find the equations of the straight lines which approximation following the data here. Find the equation of a straight line which approximation following data. So that we have a data here. That is, we have your xi and yi equals to fxi, which has been, this is 1, 2, 3, 4, 6, 8. This has been 2, 3, 4, 4, 5 and 6. So for that we have 6 data points, that has been n equals to which let us following preparing for this, that has been n equals to 6 here. So we go ahead for the same. We made it a table which has been I, then xi, yi, then xi square, and then xi yi. So for that it will be on 1, 2, 3, 4, 5 and 6. So for the same we go ahead. So for the same it will be 1 for 1, xi1, yi1, 2, then xi square is 1, and x and y 2 ones are 2, it will be 2. For the another one it will be 2, this has been the 3, 2 2s are 4, that has been x square, and xi 2 3s are 6, so that has been the 6 we have. For the xi, when xi is 3 and yi is 4, so 3 3s are 9 and 4 3s are 12. Then it will be your 4, and this has been the 4 as well, so 4 4s are 16 and 4 4s are again has been 16. This is your 6, this is your 5. So for that 6 6 are 36 and 6 5s are 30. This is being your 8, it will be 6. And so that is 8 8s are 64 and 8 6 are as your 48. For the sum we talk about it, so yes, we'll do that. Sum of 6 n equals to 1 xi equals to 24 plus 6 I equals to 1 yi equals to 24, 6 I equals to 1 xi square equals to 130, 6 n equals to I equals to 1 xi yi equals to 140. Now for the same we go ahead. So from the equation that we get, then I equals to 1, yi equals to na plus b, and I equals to 1, xi. Putting the values of sigma xi and sigma yi and n from the table, will get 24 equals to 6a plus 24b, which is further 4 equals to a plus 4b. From the equation we get sigma ni equals to 1, xi yi equals to a, n I equals to 1, xi plus b, sigma n I equals to 1, xi square. Putting the values of sigma xi and yi and xi sigma xi square from the table, will get that 114 equals to 24a plus 130b. So for the equation 1 and 2, a and b, we get a equals to 1.8824 and b equals to 0.5294, with a straight line approximation that will be given here, and that the equation will form here is y equals to a plus bx. Putting the values of a and b, we'll get here is y equals to 1.8824 plus 0.5294x. That what we'll have to discuss, and that is, this is the required straight line fit for a given data. Now we go ahead further, which we'll talk about it. That is another important question here, and which is we go ahead, fit a straight line for the following data and evaluate value y at x equals to 4.5. So the values we have, this is x and this is y. So when 1, so it will be 0.5, 2 2.3, 3 2.1, 4 is 4.2, 5 3.6, 6 5.8, and 7 5.5. So we go ahead here, we made a table for it. This is for I, this is for xi, this is for xi square, and this is for xi and yi, which we had made a table in the last question as in this class only. So that what we'll have to consider about it, and that what we'll have to discuss as well. So for the same, we go ahead here and we made a table for it, and which is being the important one. Xi and then your yi, then xi square and then y square. That is what we'll have. 1 2 3 4 5 6 7 that what we'll have to discuss here. So we go ahead to make it, and what we'll have to discuss as well is about 1 0.5, then it is will be the 1 square is 1, and that is being 0.5, 2 2.3, 4 and 4.6. Next we have your value that we have to talk about it. So for the same, it will be 3 when xi is 3 and yi is 2.1. This has been 3 3s are 9 and 3 1s are 3 and 3 2s are 6, so that is being 6.3. If it is 4 and this has been the 4.2, 4 4s are square, that has been the 16, and 4 2s are 8 and 4 4s are 16, so 16.8. Next is 5 and 3.6. 5 5s are your 25 and 5 6 are 30, 0 1 carry, sorry 3 carry, 5 6 are 15 plus 3, that has been 18, 13.0 or 18, you can say that. It has been the 6 3.8, this is 36 and this is 34.8. For the 7 it will be this is 5.5, what will be here 49 and 38.5. For sigma xi equals to 28, sigma yi equals to 24, sigma xi square equals to 140, and sigma xi yi equals to 119.5 when you add it up. So for the same we go ahead that we get as an equation here, and that has been the important one of course. For that, sigma n I equals to 1, yi equals to na plus b, sigma n I equals to 1 xi, that we have. And for putting the values from the table, it will be your 24 equals to 7a plus 28b. So from the equation we get to find it out. So for the same we go ahead here, which has been sigma and I equals to 1 xi yi equals to a, sigma n I equals to 1 xi plus b n I equals to 1 xi square. Putting the values from the table we'll get here 119.5 equals to 28a plus 140b. Solving the above equation for this a and b, we get here which has been a equals to 0.071429 and b equals to 0.839286. The straight line equation that to be given as we have y equals to a plus bx. Putting the values in the equation we get y equals to 0.071429 plus 0.839286x. This is the required straight line that fit for a given data, and we are putting the x equals to 4.5 in the equation. We get y 4.5 equals to 0.071429 plus 0.839286, 4.5, which has been equals to 3.848216. Now we go ahead further, which will be having another question that has been the important one. So the question is, a table below gives the temperature T degrees Celsius and length 1 mm at a heated rod, and if L equals to A0 plus A1T, then find the best value for A0 and A1. One mm of heated rod, if equals to A0 plus A1T, find the best values of A0 and A1. So we made a table here. That has been the temperature and this has been the length. This is, you have 20 degree, 30 degree, 40 degree, 50 degree, 60 degree and 70 degree. Okay, so for that we talk about it. This is the 800.3, 800.4, 800.6, 800.7, 801.0. So following table that can be formed for the table here that we get here the value. So we have here so for the value we get here is we put the value is for T1, TI, then you have your LI, then TI square and TI LI. This is for 20, 30, 40, 50, 60 and then 70. For that it will be your 800.3, TI square is your 400, then your 2020 is a 400 and TI LI that is being it will be 16006. TI is your 804.4 LI and that is being this has been LI. TI square is your 30 30 30 is 900 and it will be your 24012. For the another one is 40 and that is this is will be 800.6. It will be 1600. 4 fours are 16 and 2 zeros, and when it will be that is being 32024. For 55 fives are 25, so it will be 800.7. This is 2500. This is being 40035. For 6 6 are 36 36. Oh sorry, the value we have 800.9. This is 3600 and this is 48054. This has been 801.0. Then it's another 49 that has been and 56070. Sigma of that is we have your TI equals to 270, sigma LI equals to 4803.9, sigma TI square equals to 13900 and sigma TI LI equals to 216201. That we have for the following equation that are formed from the above table. It will be 4803.9 equals to 6A0 plus 270A1. Further it will be 216201 equals to 270A0 plus 13900A1. Solving the equation for A0 and A1 will get A0 equals to 800 and A1 equals to 0.0146. So there are the best two values of A0 and A1 that what we had find it out. Now we go ahead for the next one that is being the polynomial variation fitting for a second degree parabola. So that we'll have to discuss here, which will be the another one, and that what been important one to discuss here. So that is being the polynomial regression, which is a fitting a second degree parabola that we have to discuss here. So for the same here, that is polynomial regression fitting for the second degree, that what we'll have to discuss here, that is being the parabol we have for the values that we have for this, and which is being the following. Second order polynomial is being approximated y equals to a plus bx plus cx square, and for the set of the equation that called the normal equation that are formed for the following a, b and c. So that we'll get here sigma n I equals to 1, yi equals to na plus b, sigma n I equals to 1 xi plus c, sigma n I equals to 1 xi square. The next we have sigma n I equals to 1 xi, yi equals to a, ni equals to 1 xi plus b, sigma ni equals to 1 xi square equals to c, sigma ni equals to 1, and that is being your xi cube. For the next we talk about it, sigma ni equals to 1 xi square, yi equals to a, sigma ni equals to 1 xi square plus b, sigma ni equals to 1 xi cube plus c, sigma ni equals to 1 xi 4, that we have to talk about it. So here xi, yi, that is being I equals to 1, 2, 10, and that are data points which we have to talk about it. So we have the another questions for the same, and that what we'll have to discuss here, that is being the remaining one. The question being when we are going to make a table, and then we'll go ahead for the solution for the same as well, which is being the important one. So here we're going to end up with this, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than this, if I'm talking about, yes, we have to cover up the many of the questions related to it. We have covered up the sociology and software engineering. We had done your chemistry for class 11th and class 12th for part 1, and that has been the part 1 for class 12. We had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 with their SAM, the conversions, logarithms, anti-logs. After talking about that, we had done your reasoning. In that we had done verbal reasoning, where in verbal reasoning we had done general mental ability in the logic reasoning. In non-verbal reasoning we had done series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation, analysis, and practice question set as well. After talking about that, yeah, we are done your ER diagram. We are dealing with English vocabulary. We are dealing with quantitative aptitude. In that we had started with arithmetical ability. In that we had done operations on numbers, SCF and NCF of numbers, decimal fraction, simplification, square roots and cube roots, problems on numbers, problems on ages, sums and indices, percentage, profit and loss, ratio and proportion, partnership, and then again we'll do the next coming further classes. Will cover up the quantitative aptitude as well. After talking about that, coming towards that, yes, we had in many of the related to, we'll start discussing about physics part 1 NCRT. That has been the important one. We surely been started with that. Coming towards the computer based numerical and statistical technique, where we had covered up the unit 1, which has been the computer arithmetic errors and roots of equation. We had covered up floating point arithmetic, machine obstacle, round of errors, chopping error, truncation error, associated and distributive law of floating point arithmetic, inherent error, error propagation, numerical instability. In rules of equation we had covered up the second method, Newton-Raphson method, fixed point iteration method, and as well as for the simple rules, derivations of their rate of the conversions, attic and acceleration of conversions, and modified Newton-Raphson method. And for the multiple roots, Burge-Barton method for polynomial, Boy-Stroop method for the quadratic factor, and computer algorithm of these methods as well. Coming towards unit 2, which has been the interpolations and curve fitting, we have to cover up algorithm, and that is error analysis of Lagrange and the Newton's divided differences interpolation, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, natural spline Chebyshev polynomial approximation, and cause economization of the power series. In curve fitting, we had covered up the linear and the linear least square approximation, conditioning in the least square method, a Gram-Schmidt's process of orthogonalization, complete algorithm of the least squares curve fitting. In unit 3rd, we have to cover up the differentiation and integration. In that, we had to cover up which has been your methods based on the interpolations and the finite differences, retards and extrapolation. In integration, we have to cover up the errors analysis of the trapezoidal and Simpson method, Newton's codes integration method, Gaussian integration method, Gauss-Lagrange method, Lobato integration method, Radau integration method, errors comes in pertaining to method as well. After talking about that, yes, we had done your unit 4. We will have to start discussing about that again, the solutions of simultaneous linear algebraic equation. We have to cover the cause elimination method, conditional system, the condition numbers, successive and relaxive method, rate of the conversion, solutions of ordinary, that is in the differential equation. We have to cover the single step method, Rangi Kutta second order, third order, fourth order method, multiple step method, that is predicated, and the corrective method. In statistical technique, we have to cover the statistical hypothesis, types of hypothesis, type 1, type 2 errors, that is being at the level of significance, and tests involving normal distribution that we have to cover up here. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box.